Consciousness-centric universes. The idea of consciousness-centric universes suggests that consciousness plays a central role in shaping reality. In this view, the universe might exist because conscious beings observe it, or consciousness itself might create universes. It's a big shift from the way we usually think about the world, where physical objects and events exist independently of us. This idea connects to a concept in quantum mechanics. At the smallest levels of reality, particles behave in strange ways. They don't seem to exist in a single state until they are observed. For example, a particle might be in multiple places at once, but the act of observing it forces it to choose one location. This has led some scientists and philosophers to wonder, does the universe depend on consciousness to exist? One interpretation of quantum mechanics suggests that observation isn't just a passive act. Instead, it might actively shape reality. If this is true, consciousness could be more than just something happening in your brain. It could be tied to how the universe works at a fundamental level. Imagine a tree falling in a forest. If no one is there to hear it, does it still make a sound? In the consciousness-centric view, the more important question might be, if no one observes the tree, does it even fall? Or does the tree exist at all? This way of thinking suggests that the universe might not exist in a fully realized form until someone observes it. Universe might not exist in a fully realized form until someone observes it. Another idea within this concept is that consciousness might not just observe the universe, it might create it. Your thoughts, dreams, and even your imagination could generate entire realities. While this might sound far-fetched, it's not completely out of line with certain interpretations of quantum mechanics. Some theories suggest that reality is deeply tied to information, and consciousness might be a way of organizing or generating that information. Think of your dreams. When you dream, your mind creates vivid experiences complete with people, places, and events. These dream worlds feel real while you're in them. What if the act of thinking or dreaming creates small temporary universes? These universes might not last long, or they might not have the same rules as the physical world, but they could still exist in some form. In a consciousness-centric universe, the relationship between you and the cosmos could be more personal than we usually imagine. Instead of being a small, unimportant part of a vast, uncaring universe, you might be a key piece of how the universe exists at all. Your consciousness could shape the way you experience reality, and reality itself might depend on the collective awareness of all conscious beings. If consciousness creates or shapes reality, this changes how we think about life in the universe. For one, it challenges the idea that physical matter is the most real thing. Instead, consciousness might be the foundation of everything. This could also mean that our thoughts and perceptions have more power than we realize. It might even explain certain mysteries, like why the universe seems so perfectly suited for life. Scientists often wonder why the laws of physics are just right for creating stars, planets, and living beings. In a consciousness-centric view, the universe might be fine-tuned because consciousness needs it to be. One challenge with consciousness-centric universes is that they are hard to test scientifically. Consciousness itself is still not well understood. We don't know exactly what it is or how it works, let alone how it might interact with the universe. However, some researchers are exploring whether consciousness can influence physical systems, such as through experiments on decision-making and randomness. These studies are in their early stages, but they hint at a deeper connection between mind and matter. The idea of consciousness-centric universes also has connections to philosophy and spirituality. Many ancient traditions suggest that the universe and the mind are linked. For example, some forms of Buddhism teach that reality is shaped by the mind, while certain Hindu philosophies suggest that the self and the universe are one. These ideas, while not scientific, align in interesting ways with the concept of consciousness-centric universes. The idea of consciousness-centric universes invites us to rethink our place in the cosmos. Instead of being passive observers in a pre-existing world, we might be active participants or even creators of reality. Whether or not this idea is true, it challenges us to explore the deep mystery of consciousness and its role in the universe. Perhaps the act of thinking about this idea is itself shaping the universe in ways we can't yet imagine. Mathematical universe hypothesis. The mathematical universe hypothesis, MUH, is the idea that our universe is not just described by math, but is math. In other words, the universe and everything in it, stars, planets, particles, and even you, can be seen as a mathematical structure. This view suggests that mathematics doesn't just explain reality, it is reality. Think about how we use math to describe the world. We can use equations to explain how planets move, how light travels, or how particles behave. The mathematical universe hypothesis goes a step further. It says that the universe exists because it can be represented by mathematical patterns and relationships. These patterns don't just describe the universe, they are the universe. Imagine a triangle. It doesn't matter whether you draw it on paper, carve it into stone, or just imagine it in your mind. The triangle's properties, like its angles adding up to 180 degrees, are true no matter where or how the triangle exists. According to Mu-H, the entire universe works the same way. It exists because the math behind it is true, independent of any physical form. This idea was proposed by physicist Max Tegmark. He noticed how deeply mathematics is woven into our understanding of the universe. For example, the laws of physics are expressed in mathematical terms, and they work consistently across time and space. Whether you're studying gravity, electricity, or the expansion of the universe, math always seems to be the key. Tegmark argued that if mathematics is so fundamental to our understanding of reality, maybe reality itself is purely mathematical. He suggested that all possible mathematical structures exist, and the universe we experience is just one of them. If the mathematical universe hypothesis is correct, it changes how we experience is just one of them. If the mathematical universe hypothesis is correct, it changes how we think about reality. It suggests that physical objects like rocks and trees are not fundamentally stuff. Instead, they are patterns in a vast mathematical framework. Even things like consciousness or emotions could be explained as complex arrangements within this framework. This view also has implications for other universes. If all mathematical structures exist, then other universes could be based on entirely different mathematics. These universes might have different laws of physics, or they might look completely alien to anything we can imagine. Consider how video games work. A video game world is built from code, mathematics, and algorithms that define the game's rules. Characters in the game, like a pixelated hero, don't exist physically. They exist because the math behind the game allows them to. In a similar way, Mach suggests that our universe is the result of an underlying mathematical structure. Not everyone agrees with the mathematical universe hypothesis. Mach suggests that our universe is the result of an underlying mathematical structure. Not everyone agrees with the mathematical universe hypothesis. One question is whether mathematics exists on its own, or if it's something humans invent to make sense of the world. Critics argue that math might just be a tool we use, not the foundation of reality. Another challenge is that Mu-H is hard to test. It's a philosophical idea as much as a scientific one. We can't prove that the universe is purely mathematical, just like we can't prove the opposite. Still, the hypothesis provides a way to think about why the universe works so well with math. If Mu-H is correct, it suggests that everything in the universe is connected by mathematical relationships. The stars in the sky, the atoms in your body, and even your thoughts could all be seen as parts of the same mathematical system. It also raises big questions like, why do we experience the universe the way we do if it's just math? Are there other mathematical structures out there, forming other universes? Can we discover deeper mathematical patterns that explain things we don't yet understand? The mathematical universe hypothesis takes an abstract idea, math, and places it at the center of everything. It suggests that math isn't just a language we use to describe the universe, but the actual fabric of reality. Whether or not this is true, it helps us see the universe as something profoundly logical and interconnected. The next time you look at a star or think about the laws of nature, consider this. Those stars, those laws, and even you might not just follow math, you might be math. If this hypothesis is true, then our universe is a living, breathing expression of mathematics, a puzzle waiting for us to solve. The time is a multiverse idea suggests that time doesn't flow like a river moving from the past to the future. Instead, every moment, past, present, and future, exists at the same time, like pages in a book. Each moment is its own universe, complete and unchanging. We only experience one page at a time because our consciousness moves through these moments in a sequence. This idea comes from a branch of physics called space-time theory. In this view, the universe isn't just three-dimensional. Time is the fourth dimension, and it's woven together with the others to form a structure called space-time. Imagine space-time as a loaf of bread. Each slice of the loaf represents a moment in time. All the slices exist together, but you only see one slice at a time. To understand this better, let's think about how time feels in everyday life. It seems like the present is happening now, the past is gone, and the future hasn't happened yet. But according to the time as a multiverse idea, that's just how we experience time. In reality, the past isn't gone, it still exists. The future isn't waiting to happen, it's already there. Every moment exists all at once, like snapshots in an infinite photo album. Our sense of time moving forward might be like flipping through the pages of a book. You can only read one page at a time, but the other pages are still there. If this idea is true, then every version of you, past, present, and future, exists in its own universe. These universes don't change or interact with each other because they're fixed in space-time. The you reading this now exists in one universe. The you eating breakfast this morning exists in another. The you 10 years from now exists in yet another. But here's the interesting part. The future might already be set. If all moments exist at once, then what we call the future is just as real as the present. It's already there, waiting for you to experience it. This challenges how we think about free will. Are your choices shaping the future, or are you just living out what's already written in the book of space-time? Imagine you're watching a movie. You see the story unfold one scene at a time, and it feels like the characters are making decisions in real time. But the entire movie, beginning, middle, and end, already exists on the film reel. The characters aren't changing the story, they're just following the scenes that were filmed. In the same way, the time as a multiverse idea says that your life is like a movie reel. Every moment is already there, but you're only experiencing one frame at a time. If every moment exists at once, it raises the question, can we visit the past or future? Some scientists think it might be possible, at least in theory. If you could step outside your normal flow of time, you could move to a different slice of the space-time loaf. This is what people often imagine when they think of time travel. However, even if time travel is possible, it's not clear if you could change anything. If the past and future are fixed, traveling to another moment might be like visiting a painting in a museum. You can look at it, but you can't alter it. Other multiverse theories, like the many worlds interpretation, focus on different outcomes or realities branching off from one another. Time as a multiverse doesn't involve branching. Instead, it suggests that every moment is a self-contained universe. These universes don't interact. They just exist side by side in the structure of space-time. One mystery of this idea is how consciousness fits in. If every moment exists at once, why do we only experience one moment at a time? And why do we feel like time is moving forward? Some scientists think that our brains create this sense of flow. Our minds might act like a needle on a record, moving along the grooves of time. The record already has all the songs, but we hear them in sequence. This idea can change how we think about life and death. If every moment exists forever, then the moments you cherish never truly disappear. They remain as part of the space-time structure. The same is true for moments of loss or pain. They don't vanish, they just exist in their own universes. It also means that your future already exists. Instead of feeling uncertain about what's ahead, you might think of it as a part of the universe you haven't experienced yet. The time as a multiverse idea comes from how scientists understand space-time, but it's still just a way of interpreting the universe. We don't have proof that all moments exist simultaneously, and it's hard to test. But it's a logical way to think about time if you accept the idea that space-time is a single, unchanging structure. The time as a multiverse idea reminds us that time might not be as simple as it seems. Every moment from your first steps as a child to the moment you're in now could exist together in an eternal space-time structure. Whether or not we ever fully understand time, this concept challenges us to see our lives and the universe itself in a new way. Brain cosmology. Brain cosmology is an idea about how our universe might fit into a larger, more complex reality. It comes from string theory, which tries to explain how the smallest building blocks of the universe work. Brain cosmology suggests that our universe isn't the whole picture. Instead, it might be like a sheet or brain floating in a much bigger space. The word brain comes from membrane. You can think of a brain as a thin, flexible sheet. Brains can exist in many dimensions, but in this idea, our universe is a three-dimensional brain inside a larger space called the bulk. The bulk has more dimensions than we can see or experience. Imagine our universe as a trampoline. Everything we know, stars, planets, you, me, is stuck on the surface of the trampoline. But the trampoline is in a bigger room. That room is the bulk. The objects on the trampoline can't easily leave its surface, just like we can't leave our brain to explore the bulk. The bulk is where brains, including ours, exist. Other brains might be floating in the bulk alongside ours. These other brains could hold entirely different universes, each with its own rules of physics. Some of these universes might be similar to ours, while others might be completely alien. Even though brains are separate, they might interact. If two brains get close, they could bump into each other. Some scientists think this kind of collision could explain the Big Bang, which is how our universe started. Brain cosmology also tries to explain why gravity is weaker than other forces, like electricity or magnetism. According to this idea, gravity might not be stuck to our brain. Instead, it could spread out into the bulk. This would make it feel weaker in our universe because it's being shared across the larger space. Think of it like this. If you pour water onto a flat surface, it forms a small puddle. The water stays concentrated. But if you pour the same water onto a sponge, it spreads out and looks smaller. In brain cosmology, the bulk is like the sponge, and gravity spreads out into it, making it weaker in our universe. Brain cosmology depends on the idea that the universe has more dimensions than the three we experience: length, width, and height. We're used to thinking of the universe as 3D plus time. But in brain cosmology, the bulk could have many more dimensions we can't see or feel. These extra dimensions might be curled up so small that we don't notice them. Some scientists think these extra dimensions could explain strange phenomena like dark matter. Dark matter is an invisible substance that seems to make up most of the universe's mass. If it exists, it could be the result of interactions with something in the bulk or another brain. One of the most interesting ideas in brain cosmology is that brain collisions might explain the origin of our universe. If two brains collide, the energy released could create a universe. Some scientists believe this is what caused the Big Bang. In this view, the Big Bang wasn't the beginning of everything. Bang. In this view, the Big Bang wasn't the beginning of everything. Instead, it was just one event in a much larger, ongoing process involving brains in the bulk. Collisions might also create ripples in the bulk, like the ripples you see when you throw a stone into water. These ripples could affect our universe in subtle ways, possibly explaining mysteries about how space and time behave. If brain cosmology is true, it changes how we think about our place in the universe. It means our universe is just one part of a much bigger system. Other universes might exist on brains floating near ours, but we can't interact with them directly. Still, their presence could affect us in small ways, like through gravity or other forces. Testing brain cosmology is challenging because we can't see or interact with the bulk or other brains directly. However, scientists look for clues in how gravity works or in the early history of the universe. For example, tiny variations in the cosmic microwave background, the faint glow left over from the Big Bang, might hint at interactions between brains. Experiments involving particle physics, like those at the Large Hadron Collider, might also provide evidence. If scientists discover particles that seem to leak into extra dimensions, it could support the idea of brains and the bulk. Brain cosmology gives us a way to think about questions we've been asking for centuries. Where did the universe come from? What else is out there? It's an attempt to go beyond the boundaries of what we know and imagine a larger reality that includes our universe and others. Even if we can't prove this idea right now, it helps scientists explore new possibilities. It also reminds us that the universe might be more complex and more fascinating than we can currently understand. Brain cosmology paints a picture of the universe as one part of a vast, multidimensional structure. Our universe is like a sheet floating in an enormous space, alongside other universes we can't see. If this idea is true, it could help answer some of the biggest mysteries in science and show us that reality is even stranger than we imagined. Parallel dimensions. Parallel dimensions are a way to think about worlds that exist alongside ours, but in a way we can't easily see or touch. These dimensions might share the same space as ours, but they're separated by barriers we don't yet understand. They could follow different rules of physics, have different histories, or even look completely unlike anything we can imagine. To understand parallel dimensions, think about a sheet of paper. Now imagine another sheet of paper lying right on top of it. Each sheet represents a dimension, and even though they're close together, the people or objects on one sheet can't interact with the other. In this analogy, The sheets are parallel because they never touch or overlap in a way that allows them to connect. Scientists use this idea to explain certain mysteries in physics. For example, some theories suggest that parallel dimensions might explain why gravity seems so weak compared to other forces. Gravity might leak into these hidden dimensions compared to other forces. Gravity might leak into these hidden dimensions, making it appear weaker in our world. The concept of parallel dimensions comes from string theory, a branch of physics that tries to explain how everything in the universe is connected. String theory says that all matter and energy come from tiny vibrating strings of energy. These strings don't just exist in the three dimensions we're familiar with: length, width, height. They might vibrate in as many as 10 or 11 dimensions. Most of these extra dimensions would be curled up so tightly that we can't see or experience them. However, some might be large and parallel to ours. If that's true, they could hold entirely separate worlds with their own space, time, and rules. Parallel dimensions are often used in science fiction to explain strange phenomena, but even in real life, we sometimes wonder if they might be responsible for things we can't explain. For example, déjà vu. Some people believe the feeling of already having experienced something might be caused by a brief connection with a parallel dimension. Ghost sightings. Could what we think of as ghosts actually be glimpses of another dimension that overlaps with ours for a moment? While these ideas are fun to think about, there's no scientific proof linking such events to parallel dimensions. There are several serious scientific ideas about how parallel dimensions might work. Brain theory. In this theory, our universe is a three-dimensional brain floating in a higher dimensional space. Other brains might exist nearby, each with its own universe. Occasionally, brains could collide, creating phenomena like the Big Bang. Multiverse hypothesis. Some scientists suggest that our universe is just one of many in a larger multiverse. These universes might be parallel to ours, each existing in its own separate bubble. Quantum mechanics. In quantum mechanics, particles can exist in many states at once, a phenomenon called superposition. Some interpretations suggest that these states could represent different realities in parallel dimensions. Extra dimensions in string theory. String theory predicts that some dimensions are too small for us to detect, but if larger extra dimensions exist, they could hold entire worlds that we're unable to perceive. One big question is, if parallel dimensions exist, why can't we see or interact with them? The simplest answer is that they're separated from us by barriers that we don't yet know how to cross. These barriers could be physical, like differences in how time or space works, or they could involve forces that we haven't discovered yet. Some theories suggest that the only way to interact with a parallel dimension would be through extreme conditions, like the intense energy around black holes or at the start of the universe during the Big Bang. Parallel dimensions could be almost anything. Some might look like our universe, with stars, planets, and galaxies. Others might be completely alien with different physical laws. For example, a parallel dimension might have no gravity. Time might flow backward instead of forward. Space might curve in ways we can't imagine. There's even a possibility that parallel dimensions could have their own versions of you, living different lives based on choices you didn't make. Scientists are exploring ways to detect parallel dimensions, but it's not easy. One idea involves high-energy particle experiments, like those done at the Large Hadron Collider. These experiments might create tiny, temporary black holes that could hint at the presence of other dimensions. Another approach involves studying gravity. If gravity does leak into parallel dimensions, we might find evidence by studying how it behaves on very small or very large scales. Parallel dimensions aren't just a fun idea. They could help answer big questions about our universe. For example, why does the universe behave the way it does? Why are the physical constants like the speed of light what they are? Could life exist in places beyond our universe? If parallel dimensions are real, they would completely change how we see reality. They would show us that our universe is just one piece of a much larger puzzle. Parallel dimensions may sound like science fiction, but they're based on serious scientific ideas. While we may not be able to visit or interact with them yet, their existence could explain some of the biggest mysteries in physics. Whether they're hidden just beyond our reach or completely different from anything we know, parallel dimensions remind us that the universe is far more complex than it seems. Somewhere out there, or right next to you, another reality might be unfolding in ways we can only imagine. Holographic universe. The holographic universe idea suggests that our entire universe might be like a hologram. This doesn't mean it's fake or imaginary. Instead, it means everything we experience in 3 dimensions, space, time, and matter, might be a projection of information stored on a 2-dimensional surface. To understand this, think about a hologram. A hologram is a flat, 2D image that looks 3-dimensional when light hits it in a certain way. The holographic universe theory works similarly. It suggests that everything we see and feel as real could come from information encoded on a distant flat surface, much like a hologram projecting into space. The holographic universe theory comes from physics, specifically studies of black holes. Scientists discovered something strange about black holes. When objects fall into one, the amount of information the black hole can hold doesn't depend on the object's volume. Instead, it depends on the surface area of the black hole's event horizon, the boundary around it. This finding led scientists to ask, could the information of our entire universe also be stored on a surface rather than spread out through the universe itself? In this view, the universe we live in is like a 3D projection of this 2D information. The idea is tied to quantum mechanics and general relativity, 2 fundamental theories of physics. These theories don't always agree with each other, but the holographic principle could be a way to bring them together. If the universe works like a hologram, then everything we see, from galaxies to atoms, emerges from information stored on a faraway surface. This surface might be located at the edges of the universe, but we can't see or touch it directly. Instead, we experience its effects as our 3D reality. The holographic universe doesn't mean our world isn't real. You can still touch objects, see the stars, and live your life as normal. What it does mean is that the nature of reality might be different from what we assume. Instead of existing as solid and separate, everything could be interconnected, built from the same underlying information. Think of it like a video game. Built from the same underlying information. Think of it like a video game. When you play, everything looks like a real 3D world, but the game is actually made of code, a flat, digital set of instructions that creates the illusion of depth and space. The holographic principle suggests our universe might work in a similar way. If the universe is a hologram, it could help us understand how the laws of physics work. It might explain why quantum mechanics and relativity, 2 theories that usually clash, could fit together in a larger framework. Scientists are still exploring these ideas, but the holographic principle could provide clues about the universe's deepest mysteries, including what happens inside black holes and what the universe was like at the very beginning. The holographic universe theory is still an idea, not a proven fact. However, there are some intriguing hints that support it. For example, black holes. The discovery that black holes store information on their surfaces sparked the idea. Cosmic noise. Some researchers have studied tiny irregularities in space-time that might point to the universe being pixelated, like a hologram. Still, these are early findings, and much more research is needed to confirm or refute the theory. If the holographic universe is real, it might mean that reality isn't just about the objects and events we see around us. Instead, everything could be part of a deeper, hidden structure that we're only beginning to understand. It challenges us to think differently about what real means and reminds us that the universe may hold surprises far beyond our current knowledge. The holographic universe is a bold and exciting idea. Knowledge. The holographic universe is a bold and exciting idea. Whether or not it's true, it encourages us to keep asking big questions about the nature of existence. Just as a hologram can reveal hidden details when you look closely, the universe itself may have layers of reality waiting to be uncovered. Simulated universes. The idea of simulated universes is simple. What we experience as reality might not be real at all. Instead, it could be a simulation, much like a highly advanced computer program. Everything we see, hear, and touch, our entire world, could be artificial, created by beings or systems far beyond our understanding. This concept raises big questions about what it means to exist and whether we can trust our senses. The idea of simulated universes comes from the simulation hypothesis. It suggests that a highly advanced civilization capable of building extremely powerful computers could simulate entire worlds. These worlds wouldn't just look real, they would feel real to the beings living inside them. If this is possible, there could be many simulated universes, and we might be living in one of them. Imagine playing a video game. In a game, there are characters, landscapes, and rules that control how things work. To the characters in the game, their world seems complete and real, even though it's just lines of code. Now imagine that the game is so advanced that the characters become self-aware. They start to think, feel, and wonder about their existence. That's one way to think about simulated universes. We might be like those characters, living in a world designed by someone else. There are many reasons why an advanced civilization might build simulations. Here are a few possibilities. Scientific research. They might want to study how civilizations develop over time or explore different versions of history. Entertainment. Simulated worlds could be created for fun, like incredibly advanced video games. Preservation. They might want to preserve their own history by creating simulations of their past. Testing new ideas. Simulations could help them test different scenarios, such as new technologies or ways to organize society. If any of these reasons make sense, it's possible that simulations are very common in advanced civilizations. And if they're common, the chances that we are living in a base reality, the original non-simulated universe, might be very small. If we live in a simulated universe, would there be any way to know? This is a tricky question, but some scientists and philosophers have suggested a few clues we might look for. Unusual patterns in physics. If the rules of our universe are based on a simulation, they might not be perfect. We might find glitches or limits, like tiny inconsistencies in how particles behave. Digital signatures. Some researchers think we might find evidence of a grid or structure in the universe, similar to how pixels make up a digital image. Complexity limits. A simulation would have limits, no matter how advanced it is. For example, the number of particles or events it can handle at once might be capped. So far, we haven't found any clear evidence that our universe is a simulation. However, the idea remains hard to disprove. If the simulation is well designed, it might be impossible to detect from the inside. The idea of simulated universes might sound like science fiction, but many serious thinkers consider it possible. Philosopher Nick Bostrom famously argued that at least one of three things must be true. No civilization ever becomes advanced enough to create simulations. Advanced civilizations can create simulations, but they choose not to. We are almost certainly living in a simulation. This argument doesn't prove we live in a simulation, but it makes the idea hard to dismiss. Even scientists like Neil deGrasse Tyson and Elon Musk have said the odds of living in base reality might be very low. If we live in a simulated universe, it changes how we think about existence. For one, it suggests that our reality has a creator, though not necessarily in the religious sense. This creator could be a person, an advanced computer, or something we can't even imagine. It also raises questions about free will. Are our thoughts and actions truly our own, or are they part of the simulation's programming? If we're in a simulation, does it mean our choices matter less, or does it make them even more special because someone designed this world for us? Finally, it changes how we think about the universe's end. If the simulation were turned off, everything we know would disappear. This is different from the natural processes that scientists believe will eventually end the universe, like heat death or a big crunch. For most of us, the idea of a simulated universe doesn't change much about our daily lives. Whether or not our reality is real, we still experience it in the same way we still have relationships, make decisions, and find meaning in the things we do. In fact, thinking about simulated universes can inspire us to explore deeper questions about existence, consciousness, and what it means to be alive. If nothing else, it's a reminder that the universe is full of mysteries we may never fully understand. The idea of simulated universes is both exciting and unsettling. It challenges what we think we know about reality and forces us to consider possibilities that go beyond our everyday experience. Whether or not we live in a simulation, the fact that we can even ask this question shows the depth of human curiosity and our endless desire to understand the world, no matter how real or unreal it might be. The quantum multiverse is an idea that comes from quantum mechanics, the science that studies how very tiny things like atoms and particles behave. It suggests that there isn't just one universe, but many. These universes exist side by side, forming what we call a multiverse. To understand this, we need to look at how particles behave in the quantum world. Unlike larger objects, particles can be in multiple states at the same time. This is called superposition. For example, an electron can be in two places at once, or it can spin in two directions at the same time. When we observe it, however, it appears to choose one state. The quantum multiverse explains this by saying that every possible outcome happens, but in separate universes. When we observe a particle, the universe splits. In one universe, the particle is in separate universes. When we observe a particle, the universe splits. In one universe, the particle is in one state. In another universe, it's in a different state. These universes don't interact with each other, but they all exist as part of the multiverse. This idea is often explained with a famous thought experiment called Schrödinger's cat. Imagine a cat in a box with a device that can release poison. The device is controlled by a particle. If the particle is in one state, the poison is released and the cat dies. If the particle is in another state, the poison isn't released and the cat lives. Before you open the box to look, the particle is in superposition. It's in both states at once. That means in a way the cat is both alive and dead at the same time, but when you open the box you only see one outcome: the cat is either alive or dead. The quantum multiverse suggests that both outcomes happen. When you open the box, the universe splits. In one universe the cat is alive, in another it's dead. Both universes are real, but you can only experience one. The quantum multiverse changes how we think about reality. It suggests that every possibility, no matter how unlikely, happens somewhere in the multiverse. If you roll a die, all 6 numbers come up, but each in its own universe. If you make a decision, every choice you could have made creates its own branch of reality. This means the multiverse is incredibly large, with countless versions of events happening all the time. There could be a universe where you became a scientist, another where you live in a different country, and another where dinosaurs never went extinct. This idea comes from the math of quantum mechanics. Scientists use something called the wave function to describe a particle's possible states. The wave function shows all the different states the particle can take. When we observe the particle, it seems to collapse into one state, but the quantum multiverse suggests the wave function doesn't collapse. Instead, the universe branches out and each possible state becomes real in its own separate universe. The quantum multiverse is a serious idea in physics, but it's hard to prove. The other universes it describes don't interact with ours, so we can't observe or measure them. This makes it more of an interpretation of quantum mechanics than a testable theory. Some scientists prefer other interpretations, like the Copenhagen interpretation, which says the wave function does collapse when observed. Despite this, the quantum multiverse is popular because it explains quantum mechanics without adding new rules or assumptions. It also helps make sense of why quantum events seem random. In the multiverse, every possible outcome happens, so nothing is truly random. If the quantum multiverse is real, then every version of you exists somewhere. For example, in one universe, you might have chosen a different career. In another, you might have met different people or made different decisions. In yet another, you might not even exist because your ancestors made different choices. These other versions of you live in their own universes, completely separate from the one you know. You'll never meet them or interact with their worlds, but they are as real as your own. The quantum multiverse changes how we think about the universe and our place in it. It suggests that reality is much bigger and more complex than we can see or experience. It also challenges the idea that our choices and experiences are unique. Every possibility exists somewhere, even if we can't see it. This idea doesn't just apply to small particles, it applies to everything in the universe. The multiverse could contain every possible version of reality, from the smallest particle to the largest galaxy. The quantum multiverse reminds us that the universe is full of possibilities. Every time something happens, the multiverse grows, creating new branches of reality. Somewhere out there, in another universe, every version of your life exists, waiting to be imagined. Bubble universes. The bubble universe idea comes from a theory called eternal inflation, which explains how our universe might have started and what might lie beyond it. According to this idea, our universe isn't the only one. Instead, it's one bubble in a vast foam of universes, each existing separately, like bubbles in a sink full of soap suds. To understand bubble universes, we first need to understand inflation. Scientists believe that, just after the Big Bang, the universe expanded extremely fast for a very short period. This process is called inflation. After inflation slowed down, our universe began to grow at a slower rate, forming stars, galaxies, and everything we see today. But eternal inflation suggests that this process didn't stop everywhere. Some regions of space kept expanding rapidly, creating new bubbles. Each bubble becomes its own universe, with its own set of physical laws and properties. Our universe is just one of these bubbles. Each bubble universe can be completely different from ours. Some might have the same laws of physics, but others might have different rules. For example, the strength of gravity might be weaker or stronger. Light might travel at a different speed. Entirely different particles or forces might exist. In some bubbles, life might be impossible because the conditions are too harsh or too strange. In others, life might thrive, but in ways we can't imagine. Between these bubbles is a space that's constantly expanding. Can't imagine. Between these bubbles is a space that's constantly expanding. This space is often called the inflationary field. It's like the space between soap bubbles in a foam. The bubbles don't interact because the inflationary field keeps pushing them apart. This means that even though there may be countless other universes, we can't travel to or communicate with them. Our universe likely formed when a tiny part of the inflationary field slowed down and stabilized, creating a bubble. Inside this bubble, the conditions were just right for particles, atoms, and eventually stars and planets to form. This slowing down is what allowed our universe to grow and evolve into what we see today. We don't have direct evidence for bubble universes because they exist far into what we see today. We don't have direct evidence for bubble universes because they exist far beyond what we can observe. However, some clues might hint at their existence. The cosmic microwave background, CMB. The CMB is faint radiation left over from the Big Bang. Some scientists believe unusual patterns in the CMB might be caused by our bubble interacting with another bubble in the distant past. Fine-tuning of the universe. Our universe's laws and constants seem perfectly tuned for life. Bubble universe theory offers an explanation. If there are countless universes, some will have the right conditions for life by chance. The bubble universe idea suggests that our universe is just one part of a much larger reality. It changes how we think about our place in the cosmos. Instead of being the only universe, we might be one of countless others. Each bubble represents a different version of existence with its own unique story. This idea also raises questions about whether anything connects these bubbles. Could there be a way to travel between them? Could they influence each other? For now, these questions remain unanswered. Bubble universes offer a way to understand why our universe is the way it is. Instead of searching for one ultimate explanation for everything, this theory suggests that our universe is just one possibility. The physical laws and constants we observe are not universal. They're just specific to our bubble. Proving the existence of bubble universes is difficult because we can only observe what's inside our own bubble. The edge of our universe, known as the observable horizon, is the farthest point we can see. Anything beyond that is hidden from us. However, scientists continue to study clues like the cosmic microwave background and develop theories that might one day provide evidence. If bubble universes exist, they change how we see ourselves and our universe. Instead of being the center of everything, we are part of a much larger, more complex reality. Each bubble is like a storybook with its own characters, settings, and rules. Our story is just one among countless others. The next time you see bubbles floating in the air or forming in water, think of the bubble universe idea. Somewhere out there, beyond what we can see, other bubbles might exist, each holding a universe with its own unique version of reality. Our universe is just one bubble in a cosmic sea. Many worlds interpretation. The many worlds interpretation, or MWI, is a fascinating way to think about the universe and how it behaves on the smallest scales. It suggests that every time an event happens, no matter how small, the universe splits into multiple versions of itself. Each version shows a different outcome of the event. These versions or worlds exist at the same time but don't interact with each other. This idea comes from quantum mechanics, the branch of science that deals with the behavior of very tiny things like atoms and particles. In quantum mechanics, particles don't have fixed positions or states. Instead, they can exist in several states at the same time. This is called superposition. For example, a particle could spin both clockwise and counterclockwise at the same time. This is called superposition. For example, a particle could spin both clockwise and counterclockwise at the same time. But when we observe the particle, we see it in only one state. Scientists used to explain this by saying the act of observing caused the particle to choose one state, a process called wave function collapse. MWI challenges this explanation. Instead of the particle collapsing into one state, MWI says that the universe itself splits. Each possible outcome of the particle's state happens in its own version of the universe. If the particle can spin both clockwise and counterclockwise, one universe forms where it spins clockwise, and another forms where it spins counterclockwise. Both are real, but they belong to separate realities. Let's use a coin flip as an example. If you flip a coin, it can land on heads or tails. In your everyday experience, the coin lands one way, and that's the result you see. But according to MWI, the universe splits when the coin flips. In one universe, the coin lands on heads. In another, it lands on tails. Both outcomes are real, but you can only experience one of them. The other outcome happens in a universe you can't see. If MWI is correct, there could be countless versions of you living in other universes. Every choice you make creates a new branch of reality. For example, in one universe you might decide to skip breakfast, in another you eat cereal, in yet another you choose pancakes. It's not just your choices that create these branches. Every single event, even tiny ones involving particles, creates splits in the universe. That means the number of universes could be unimaginably large. MWI is one way to explain the strange behavior of particles in quantum mechanics. Without it, scientists rely on the idea of wave function collapse, which has always been hard to define clearly. MWI avoids the problem by saying that all possible outcomes happen, just in separate realities. This makes the math of quantum mechanics work without needing extra rules. Another interesting idea from MWI is that there's no randomness in the universe. In our everyday experience, quantum events, like where a particle might appear, seem random. But if every possible outcome happens in its own universe, nothing is truly random. Every possibility exists somewhere. One challenge with MWI is that it's hard to test. The other universes it describes don't interact with ours, so we can't see or measure them. This makes it an interpretation rather than a testable theory. Still, many scientists like it because it explains quantum mechanics without adding mysterious concepts like wave function collapse. MWI has interesting implications for how we think about ourselves in the universe. If it's true, then every decision you've ever made, and every decision you didn't make, exists in some version of reality. There's a universe where you chose a completely different career, met different people, or lived in a different place. These versions of you are living their own lives, unaware of your existence, just as you are unaware of theirs. The many worlds interpretation might sound like something from a science fiction story, but it's based on real science. Physicist Hugh Everett first proposed the idea in 1957. Since then, it has gained support from many scientists who study quantum mechanics. However, not everyone agrees with it, and there are other ways to interpret quantum mechanics. MWI doesn't solve every mystery of the universe, but it gives us a way to think about the strange behavior of particles and events. Whether or not it's true, it challenges us to imagine a reality far more complex and far more connected than we ever thought possible. The next time you make a decision or see something happen, remember, somewhere in the vast multiverse, another version of you is living a completely different life. Version of you is living a completely different life. Whether you're flipping a coin, choosing a path, or just watching the world go by, every possibility is out there, waiting in its own universe.